Unit 1, Question 3. The question states, a weather balloon is rising. After t hours, the distance above the ground, h of t, measured in kilometers, is given by the function h of t is equal to 8t minus t squared after t hours. Part A asks, find the average velocity of the balloon from t equals 2 hours to t equals 5 hours. So the first step to finding the average velocity of the balloon is between t equals 2 and t equals 5 is to plug it into the original equation. So first we would plug in 2, making it 8 times 2 minus 2 squared. So that would be 16 minus 4, which would give 12. And since we're dealing with distance here, it's in kilometers. Now, we have to take the h at 5. So it would be 8 times 5 minus 5 squared, which would give 40 minus 25, which is 15 kilometers. To find the velocity average, we would have to take h at 5 minus h at 2 over the given interval, subtracting each other. So V average is h at 5 minus h at 2 divided by the given interval, which is 5 minus 2. So what we got was 15 minus 12 over 5 minus 2, which is 3 over 3, which is just equal to 1. And since this is velocity, it's 1 kilometer an hour. And that's part A. Now, part B states, find the velocity at t equals 3 using a limit. So the first step that we have to do is find h at 3 to figure out the distance of that first. So it would be 8 times 3 minus 3 squared, which is 24 minus 9, and is 15 kilometers. Next, what we have to do is find h at 3 plus h. H is in just a variable. So 8 times 3 plus h minus 3 plus h squared. So we simplify that, which is 24 plus 8h minus, and if we just make it a binomial, these two multiply by each other. And just to skip over a step and make it a little easier, we multiply the negative into each term here as well, making it minus 9 minus 6h minus h squared. And from here, the 8 and 6 are like terms, and 24 and negative 9 are like terms. So let's put the h squared in front, plus 2h, because 8 minus 6, and then plus 15, 24 minus 9. Now, to find velocity using the limit, we have to write the limit as the variable h approaches 0. And from here, we have to take the h at 3 plus h minus the h at 3 all over the variable h. Just like that. So the limit, as h approaches 0, is what we have from the two given answers, which is negative h squared plus 2h plus 15 minus h of 3, which is 15. So here, the 15s can cancel out, and just leave it with negative h squared plus 2h over h. Now from here, since both these terms have an h in them, they can both be divided by the h in the denominator, canceling them out. So what we are left with is the limit as h approaches 0 and just negative h plus 2. And then from here we can substitute 0 since the variable h approaches 0. So it would just be negative 0 plus 2, which is just 2. And since this velocity is in kilometers per hour, so the final answer is 2 kilometers per hour.